Hello, this is me, Derpskull, and before this video starts, I just wanted to say I had a lot of fun making this. It's a bit different from my usual type of content, but I do hope you enjoy it. It was a project I decided to work on to see if I ever wanted to make more serious videos. You may notice the microphone quality is quite better because I have one set up and I had a whole bunch of studio setups, lighting. This video took me quite a few days to do. The scripts took me 2 days. The B-roll I did about an hour, and then this audio recording as of yet isn't done. I still have to do it, but anyways, if you're seeing this video, it means I did upload it and I was proud of it. Anyways, enjoy the video. Playing cards. They're a key component in many gambling, solitaire, or just for fun games, and when playing these games, whether it's poker, solitaire, war, or any of the others, it's very likely you needed to shuffle a deck of cards in order to make the game more fair. But what if you shuffled and got the same result? How unlikely is it that after you shuffle a deck, you'll end up with an arrangement you've previously encountered? Well, it's even less likely than you think. It's unlikely that, in your entire life, you'll ever shuffle a deck the same way twice. In fact, I'm even willing to say it's unlikely that a deck of cards has ever been shuffled the same way twice ever. The odds are so small, and there are so many ways, that it's actually really tricky to wrap your mind around how unlikely it all is. Maybe this video can help you get a better grasp on the ridiculously small chance of shuffling a deck the same way twice. The way to determine the probability is to look at the equation of 52 factorial. What this means is that you do 52 times 51 times 50 times 49 all the way down to 1. Obviously, you're going to think that this number is going to be massive. A billion, a trillion, maybe even a quadrillion. Not even close. The number is 8 times 10 to the power of 67, or 8 with 67 zeros after it. This is what that number looks like. Yeah, it's pretty freaking huge. So huge, in fact, that some claim that there are more ways to shuffle a deck of cards than there are atoms on the entire planet. But is this true? Well, let's do the math. I'm going to be doing this in terms of the size of carbon atoms. So, naturally, the first step is to figure out the size of a carbon atom. We can figure this out by first turning our attention to the periodic table, which says that the atomic mass of carbon is 12.0096 grams per mole. Now, to figure out the amount of grams in one atom, we can use Avogadro's number, which is 6.02 times 10 to the 23rd, so we can conclude that in 6.02 times 10 to the 23rd atoms of carbon, there are 12.0096 grams. But now, we need to figure out the mass of a singular carbon atom. So we can divide both sides by 6.02 times 10 to the 23rd, and we can get the mass of one carbon atom is 1.9949501 times 10 to the negative 23rd. Great. Now we can use that to get the volume of a carbon atom. Do the math, you'll get the volume of a carbon atom is 1.9 times 10 to the negative 30th meters cubed. That's pretty damn small. Step 2 in the process is to calculate the volume of the Earth in terms of meters cubed. The Earth is about 1 trillion kilometers cubed. 1 kilometer is equal to 1,000 meters, so the Earth is about 10 to the 15th, or 1 quadrillion meters cubed. So now next step is to divide the number of square meters on Earth by the number of square meters of one carbon atom, which will give us the amount of carbon atoms it would take to make something as large as the Earth. 1 quadrillion divided by 1.9 times 10 to the negative 30th equals 5.263157894 times 10 to the 44th. A big number for sure, but still less than 0.00001% of the number of ways to shuffle a deck of cards. But we're still not finished. We've just shown that it's bigger than the Earth. But what else is it bigger than? Our Sun is 1.3 million times larger than the Earth, essentially meaning it can fit 1.3 million Earths inside of it. If we multiply this by our previous number, you get the number of 6.842105263 times 10 to the power of 50, over a million times larger than our previous number, but still under 0.00001% the size of the number of ways to shuffle a deck of cards. So let's go even bigger. VY Canis Majoris is the biggest star that we know of in our galaxy, and is about 9.3 billion times larger than our own Sun. Multiply again, and the number of carbon atoms needed to equal the size of this beast is 6.6 It's 363,157,894 times 10 to the 60th. We're getting closer, but the number is still below 0.00001% of the number of ways to shuffle a deck of cards. In short, there is no way an object in this universe can exist at an equal size to 8 times 10 to the 67th, in terms of carbon atoms making up its structure. The amount of gravity created would cause the object to collapse in on itself infinitely, thus creating a black hole. There never was, never is, and never will be an object large enough to come close to the size of this beast of a number. So don't worry about shuffling a whole bunch, because it's so unlikely that you'll get the same result that it might as well not be possible at all. It's more likely that you'll win the lottery 100 times in a row. Just think about those odds the next time you sit around shuffling a deck. It's likely you created an arrangement of cards that's never been done before in history. Odds that a deck of cards have ever been shuffled in the same arrangement twice in the history of ever is still surprisingly pretty low. That's how insanely unlikely it is that you'll get a repeated result. But what are the exact odds that from the invention of the deck of cards to the very end of 2018, a repeated result has occurred? Well, there's no way to know for sure exactly, but we can try to estimate and do the math. Alright, for this next paragraph or so, I'm going to cite quite a few sources. The links will be down in the description for anyone who wants to take a look for themselves. Let's first figure out how long the deck of 52 cards has existed. It was first invented in China around the 9th century during the Tang Dynasty, which lasted from 618 to 907. So we'll assume that the start date is January 1st, 0800. At the time of 000000. The end date will be January 1st, 2019 of the same time. That's 1,219 years, or 444,935 days, not accounting for leap years. So let's assume that every person on Earth had a deck of cards and played one game a day. The ideal amount of times to shuffle is 7, so let's keep that as the amount of shuffles per day. Let's now figure out how many people have ever lived since 800 AD. According to www.ined.fr, 1 in 5 people to ever exist have been born in the last 2 centuries. According to the Population Reference Bureau, 107 billion people have ever existed. This means around 21.4 billion people were born between 1800 and 2019. According to www.ecology.com, population during 800 AD was around 210 million. So we can add that to our number to get 21.61 billion. Now, also according to www.ecology.com, 131.4 million people are born every year, and 55.3 million people die every year. So to figure out the gap, we can subtract 55.3 million from 131.4 million to get 76.1 million per year. Multiply that by the number of years in the gap, which is 1,000, gives us a number of 76.1 billion. Add that to our first number, and we have 97.71 billion people to have ever existed in between the two time periods. We also have 1,219 years, or 444,935 days. One game per day means everyone played 444,935 games, not accounting for deaths, so we're getting a much larger estimate than the actual number. And if they shuffled 7 times per game, each person shuffled 3,114,545 times. Multiply that by the number of people to exist, and we get our number. The amount of times a deck of cards has been shuffled from its existence to the end of 2018 is 6.730531745 times 10 to the 16th. Not even remotely close to 8 times 10 to the 67th. So the odds that an arrangement has ever been repeated, based on these calculations, is 8.41316468 times 10 to the negative 52nd%. So, not only has it most likely never happened, but it most likely will never happen for a very long time. Think about that next time you shuffle a deck. Think about how long it will be till that arrangement in your hand is repeated, if ever. Thank you guys so much for making it to the end of the video. I was thinking about this topic for a while now and thought it might be fun to make a video on. This is something different I'm trying because these are types of videos I genuinely enjoy watching. If you guys enjoyed, tell me in the comments. If this video does well, I might make another one. Trying to mix up my content a little bit, but a GD video will probably be out soon, so don't worry. Anyways, thanks for watching. All feedback's appreciated. Be sure to check out some other videos. Bye.